You ever wonder how your favorite app just knows what you want? Or how a website can juggle millions of products and find the exact one you're looking for? Well, it all goes back to a forgotten war of ideas in the 1970s that completely shaped how we handle data today. This isn't just some dusty old history lesson, it's literally the secret architecture of our entire digital world. So, let's get into it.
So here's how we're going to break it down. First, we'll see how programmers were basically navigators, charting a course through raw data. Then we'll look at the first big attempt to create order, a kind of complex but powerful web of data. After that, the revolution, a totally new idea that sparked a massive debate. We'll see why the simpler approach won out in the end and what that all means for us, right now.
All right, so picture this. It's the late 60s, early 70s. Computers are these gigantic, room-sized beasts, and trying to get any useful information out of them, it was a nightmare. The huge problem was that your program had to know the exact physical layout of the data on the disk. I mean, you had to know precisely how it was stored step by step.
And this quote right here from Don Chamberlain, one of the guys who invented SQL, it just says it all. He's talking about the old system, CODASYL, where a simple question could take 5 pages of code to answer. 5 pages! Then he sees this new way of thinking from a guy named Cod, who could do the same thing in a single line. That's not an improvement. That's a revolution.
This old approach was called a navigational database, and the name is perfect. The programmer literally had to navigate. You'd write code that said, okay, start at this record, follow this specific pointer to the next record, then follow that pointer. It was like giving turn-by-turn directions through a maze. And the craziest part? If someone changed the physical layout of the data, your entire program would just break. Kaput.
Now, it wasn't total chaos. An industry group called CODASYL stepped in to try and standardize this whole navigational thing. Their solution was called the Nework model, and for its time, it was actually pretty powerful and a whole lot more flexible than what came before.
So in 1969, CODASYL standardized this network model. The big deal was that, unlike older systems where data was in a rigid tree, this model let any piece of data link to any other piece of data. It created this intricate, flexible web of information. And it all came from the work of a guy named Charles Bachman, who's actually the one who came up with that programmer as navigator phrase.
And take a look at this. This is what that web of data actually looked like. It's called a Bachman diagram. Every box is a type of data, like president or state, and every single arrow is one of those hard-coded paths a programmer had to follow. So if you wanted to find out which state a president was from, your code had to know specifically to follow the native son's path. It worked, sure, but you can see how incredibly complex it is. You had to plan every possible question you might ever ask right from the start.
But then, right in the middle of this world of complex charts and 5-page programs, this researcher at IBM, Edgar F. Codd, comes along. And he drops an idea that was so ridiculously simple, so elegant that at first, everyone in the industry thought he was crazy. They thought there was no way it could actually work in the real world.
This quote from Codd himself is the key to his entire philosophy. He was basically saying, hey, why should a regular user have to be a computer hardware expert just to ask a simple question? He wanted to protect people from the messy details. He called this big idea data independence, and it was the absolute heart of his new relational model. And this right here shows you the genius of it. Forget those tangled webs and pointers. Codd said you can represent any data you want in simple tables. Just tables, like a spreadsheet. That's it. All that complexity from the Bachman diagram, it's just gone. It's so clean, so intuitive. So here's the magic trick. Codd separated the what from the how. He said the logical idea of your data, what it represents, should have nothing to do with how a computer physically stores it on a disk. So instead of linking records with fragile pointers, you link them based on their actual data. You want to find stuff related to President Kennedy? You just look for things that have his president ID. You tell the database what you want, and you let it worry about how to go find it.
As you can probably guess, the old guard, the whole CODASYL establishment, was not a fan of this. They thought Codd's idea was just a beautiful theory, a fantasy that would be way too slow for the real world. And that kicked off a decade-long war for the future of data.
And you can see how the battle played out right here on this timeline. You've got CODASYL setting the standard in '69. Then, boom, 1 year later, Codd drops his bombshell paper. For years, it was just a theory. But then in the mid-'70s, huge projects at IBM and Berkeley started building actual working systems to prove it was possible. The final nail in the coffin came in 1979, thanks to Patricia Sellinger. She wrote a brilliant paper that proved with math.
that you could make a relational database just as blazing fast as the old navigational ones.
Now, Selinger proved that the relational model could be fast. But here's the twist. Performance isn't why it won. The relational model won because of something way, way more powerful in the world of tech, making developers' lives easier. This chart really nails the difference. The CODASYL model was procedural. You had to tell it the step-by-step recipe for finding your data. But the relational model was declarative. You just told it what you wanted, and it figured out the recipe for you. It's the difference between being a chef and just ordering a pizza. This shift was massive. It liberated programmers from having to be hardware experts and let them ask questions about the data in ways no one had ever planned for.
And what was the payoff? A mind-blowing productivity boost. We're talking like a 10-fold increase. Remember those 5-page programs? Now you could do the same thing in just a couple of lines of SQL. And let me tell you, in the world of software, when you make your developers 10 times more productive, you don't just win an argument, you win the entire market. It's game over.
So, the relational model won. The world moved on, but the ghost of that old debate, the lessons learned, and even some of the ideas from that old CODASYL model, they still echo through the technology we all use today.
So why should you care about this old tech battle? Well, for one, it gave us data independence. That idea of separating the what from the how, which is fundamental to almost every data system we have. Second, it taught us a crucial lesson. Sometimes, making things simpler and more flexible for people is way more important than squeezing out every last drop of performance. And finally, the declarative style of SQL unlocked the door for incredible new technologies that would have been impossible in the rigid, step-by-step world of CODASYL.
Which leaves us with one last thing to think about. That whole war was really about simplicity and flexibility versus raw, complicated performance. And if you look around today, you've got this huge debate going on between traditional SQL databases and all the new NoSQL databases. So, is it just history repeating itself? Are we in the middle of another great database debate, once again trading one set of advantages for another? Something to chew on.